Alright, we're ready to tackle PETG printing again. I went online and learned a bunch of stuff about printing with this particular printer and other tips and so forth. So first thing is, apparently this printer can go to 250, even though the nominal specs are 240. And in fact, I didn't check this myself, but online they reported the Flashforge flash print software that comes with the printer will let you set it to 250. So we're going to try setting it to 250, and then we're not going to I'm going to do 250. Oh, it's changing to 248. Let's see. 250. There, oh, looks like it's maxing out at 248. I tried to set it to 250, and it's saying 248, so I guess we're going to try 248. Okay, that's fine. That's a little bit better than we had before. So we'll go back here, and then instead of using preheat, though, we're going to use load filament. Or first we're going to move the print head over, so it's over the print bed. All right, then we're going to use load filament and see if it'll actually heat up to 250. So, all right, so I'll pause here, and then we'll come back and see how high it gets up to 248 or not. One other thing is, so the reason you don't want to go too high with this particular print head is because inside the print head is a Teflon tube. And I realize now, those little short Teflon tubes that came with the printer, those are for actually replacing the tube that's in the print head. So the tube in the print head, that prevents PLA filament from melting too quickly as it passes through the print head. So you want it to melt right at the end of the print head. And so the Teflon tube acts as a little insulator. It's possible if you run your printhead too high, then the Teflon tube can deteriorate and become smaller, and then your filament won't feed. So there are all metal hot ends that I can replace this with, but they don't print PLA as well. So most of my printing is going to be PLA printing, so I don't really want to replace the filament. But if we can get a little better results with the PETG by going up to 248, then that's what I'm going to do. So, all right, so we're almost there, but I'll go ahead and pause here, and we'll see what happens when we see if the filament will load or not. All right, so 240, it's going to 241. Let's see how high it gets here. Some people said they couldn't get it to 250. It maxed out at 240, 245. So we'll see if we can actually get up above 245. 245. Oh, that's it. Okay. So let's see, is it feeding? Yeah. So I went to 245, and it is feeding. It's feeding very quickly. So we're going to stop that. Now we'll go back, and we'll see if we can actually preheat to 248. So it may max out at 244. That's what other people reported. So it's turned off the heating of the extruder while it heats the bed, which is fine. So we'll see what happens when the bed will heat up pretty quickly, but I'll come back when the bed's heated up, and we'll see how high the extruder gets. All right, actually both are heating up simultaneously now. So the extruder's up to 243. We'll see how high I can get here. See if we can got to 244. That may be the maximum. That's still an extra 4 degrees over what we had before. So that you could definitely print. We're at the 245. All right, good. 246. 247. Can we get to 248? 248. All right. Okay, so we're going to try the temperature tower again at 248 maximum temperature, and we're also going to make some other changes, which I'll show you, to the profile for this particular filament to hopefully it'll make it print better. So. All right, so we're ready to try our new higher temperatures and settings for the PETG. So we updated the pointing temperature tower in OpenSCAD. So the maximum temperature now is 248. And I cut off the bottom ones down to 230 because I figured we definitely want to move to higher temperatures, not lower temperatures. So this will speed it up a little bit. So we're going every 2 degrees again, just to give us some more choices here. So that's that. And then we're going to go over to Simplified 3D, and we'll import this, and I'll show you what the new settings are. All right, so here we are in Simplified 3D. We imported our temperature tower, so this now goes from 248 to 234. Let's look at the change we made to the process profile. So these were based on some profiles and other tips I found online. So we're going to try these and see how they work out. First thing is I changed the extrusion multiplier to 0.95. It was 1.0, so I'll have to check that, see if that helps. The other thing is to cut down on stringing. They recommend increasing the retraction distance from 1 millimeter to 2 millimeters and speed it up. So it was 1200 millimeters per minute, and now it's 1800. The other thing is we turned on these two things, coast at end and wipe nozzle. So I'm not sure how those are going to work. I think coasting is a good idea because that means when it gets to the end of a loop, it slows down, and so that you don't get blobbing overruns. And this is also supposed to prevent blobbing, so it says ooze controls. For the layers, we didn't change anything here. And over on temperatures, where you have the bed temperature of 40, which we like that. And I changed the temperature layers to match up with our new ranges. So we're going up to 248. And cooling is the same. One suggestion I had this turned off. I'm not sure why, because we want to do the best we can on bridging. So. And the speeds are also changed. So this is slowed down from, let's see, what was it originally? It was 3,600, and now it's only 2,000. So I saw this early on looking at PETG that you want to slow everything down because otherwise it doesn't print very well. So that makes your prints take longer, but that's just the trade-off, I guess. And the outline underspeed used to be 50, and now it's 100. And the solid fill underspeed is used to be 80, and now it's 100. Or yeah. And this didn't change. Also, the XY movement speeds have been lowered. XY movement was 4,200, and now it's 2,000. And the Z-axis movement was only 1,000 now instead of 1,200. So we're slowing everything down to make it print better. Now under other, no changes here. Advanced, I did turn these on, and I also decreased these like I did for other prints because it makes it for better print quality for small details. So this won't help us much probably on the temperature tower, but when we try the all-in-one test again, which I decided I'm going to do, just so we can have a direct comparison, these should help with the smaller details. All right, so that's our profile. We'll go ahead and send this to the printer. The thing I'm going to do is I'm going to leave the door open this time. With PLA, I've been printing with the door closed. That seems to work really well. Because we're at a higher temperature, we want it to cool down better as it prints. I'm going to leave the door open, and that'll help air circulation, and maybe it'll improve print quality. So, all right, so we'll send it over to the printer, and we'll switch to the time lapse. All right, so we're printing with the door open. It is printing at a slower speed. The first layer looks great, just like before. So it's slower. It's not that much slower. I really noticed it when I first moved over to the side of the bed, how much slower it's moving. About 1/3 of the speed it was before. So, I mean, 2/3 of what it was before. All right, so let's let this go, and we'll see how we do. All right, so it's done with the base. We're looking at the print in Simplify 3D's preview mode, and you can see the temperature. It's at layer 18, it increased the temperature to 248. So now it's reporting 248. So the printer is actually printing at 248. So that's good. And as we go up in the different bridges here, it'll go down from here down 246, 244, and so forth. So things are working as we expect. That's good. this off. Okay, the bed adhesion is good. Alright, let's see. I would say the printing is slightly better than the other one. Where's the other one? Slightly better. No, not that much difference. Oops, accidentally pressing the button there. So we started at 248. 248 has some sagging. They all have some sagging. .248. The bridge is more complete. Look down here, you can see the bridge did better on 248. Still some stringing. There's another test that I found online that just tests stringing, so we're going to do that next, I think. Overall, based on the back of these things, I think 248 is our best bet, so yeah. And luckily, this printer, which I didn't realize before I did this test, can handle 248. So that's a plus. Yeah. So when I print, I'm not usually printing bridges like this. I'm always using support, so I'm not really worried about the bridging, but try to do some more on the stringing, and then we'll go from there.
If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.